In this video, we'll be talking about the intermediate value theorem. And we'll do that by looking at number 38. And I'll assume for this video that you've been introduced to the intermediate value theorem, and you're ready to go on number 38, which says that we're supposed to use the intermediate value theorem to show that f of x equals 2x cubed minus 3 has a 0 on the interval 1, 2. So first of all, what does that mean to say that it has a 0? Well, when we say that a function has a 0, we mean the function equals 0, and we would mean that y equals 0. So we want to say that 2x minus 3 has to equal 0, some point between x equals 1 and x equals 2. So graphically, that might look like this. Here's x equals 1, here's x equals 2, and we want to prove that this function must equal 0 in between these 2 points. So a good way to do this would be to find what is f of 1 and what is f of 2, and then apply the intermediate value theorem. So f of 1 would be 2 times 1 cubed minus 3. And that's just going to be negative 1. f of 2 would be 2 times 2 cubed minus 3. And that's 8 times 2 is 16. Minus 3 is 13. So what that means is that from 1 to 2, our function values go from negative 1 to 13. If you remember, the intermediate value theorem says that given an interval such as 1 to 2, the function must include every value in between. So this function absolutely has to cover all the numbers between negative 1 and 13. Now remember, when we're talking about function values, we're talking about y values. So we're actually ready to give our answer. Our answer could be written as the intermediate value theorem, and we can say IVT, guarantees a value f of x equals 0, that's like saying there's a 0, on the interval 1, 2, because, and here's how we have to find a way to write that 0 falls in between the y values for these. So how do you say the y value when x equals 1? You just can call it f of 1. And then to kind of show that we did the work, we can say that this equals negative 1 is less than 0 is less than f of 2, which equaled 13. Okay, so we're saying that 0 is in between f of 1 and f of 2. And that would be your answer. Now this problem didn't ask for it, but often the problem will then ask, well, what is the x value that gave you that 0? So let's talk about how to find that. So now we proved that there has to be a 0 in here, and now they want to know, well, what is that 0? Well, that's easy enough to do. That's work that you've done before. When does this function equal 0? You just put a 0 for the function, and you solve the equation for 0. And you get x cubed equals 3 halves. So that would be the cubed root of 3 halves equals x. And that's going to be the x value that goes with y equals 0. And part of the reason I'm doing this is I want to talk to you about how to put it in your calculator. I know you can't see my calculator screen, but I can at least tell you what I'm doing. I want to find the cubed root of 3 halves. So I could use 1.5, but let's keep it as a fraction since some people may not know how to do that. you'll do parentheses 3 divided by 2. So parentheses 3 halves. And then close parentheses. And then we want to raise that to the 1/3. It's because a cube root is the same as raising something to the 1/3. So use this little caret button here, and then you type in 1 divided by 3. Hit enter, and we get our value. We get that x equals 1.447. And in calculus, we do not have to round. We'll just go to 3 decimal places. So we're saying that right here should be 1.447. And of course, we know y equals 0. So that was a little extra work on number 38, but you'll need it for a later problem anyway. So let's look at number 39 now. 39 is a question about a diver and a swimming pool. So here's a very rough sketch of the swimming pool. We have the ladder and the diving board, and here's the level of the water. So what the problem is saying is that at time 0, he was 1 meter above the level of the water. So maybe the diver was standing on the pool deck. At 4 seconds, he was about 4 meters up, so maybe he was climbing the ladder then. At 8 seconds, he was 8 meters up. He could be on the diving board. At 12 seconds, he's at -3 meters. He's probably below water then. And at 16 seconds, he's 1 meter above the water. So maybe he climbed out of the pool there. So that's what this table is showing us. Now it also said that we can assume this function, if there were a function associated with it, is continuous, because he's not going to be able to teleport. He's going to cover all these heights in between, because he's not able to teleport, which means the intermediate value theorem comes into play. So the first question says, how many times did the diver break the surface of the pool? So what does that mean, break the surface of the pool? Well, the question said that pool level or water level is a height of 0. So how many times did he achieve a height of 0? Well, the first one that comes to mind is when he goes from 8 to -3, right? So between 8 and -3, there definitely has to be a height of 0. So if he were up here on the diving board and he ended up underwater down here, right? At some point then, he had to break the surface of the water. So definitely on the interval 8-12, I guess I can use parentheses like this. 8-12, he must have broken the surface. And then from 12 to 16, we can see that he broke the surface again, because he went from underwater to 1 foot above the water. So we can say that he broke the surface of the water at least twice. That would be the answer to the first question. Now the second question is a great one. In theory, could the diver have been at pool level during the time interval 0-4? Well, it says at 0, he was at 1 foot. So maybe he's standing here on the pool deck. And at 4 seconds, he was at 4 meters. So maybe he was climbing the ladder. So at first glance, it doesn't look like he could have broken the surface of the water there. However, though this is a continuous function, we only have a few data points. We actually don't know what happened at 2, 3, or 4 seconds. Right? We only know that he didn't teleport. So actually, at 2 seconds, he could have jumped in the pool for a quick second and then gotten back out and climbed the ladder. So the answer is yes, he could have broken the surface of the water or been at pool level on the interval 0-4. And why? Because we don't have the information between 0 and 4 seconds to tell us one way or another. Okay, now the intermediate value theorem doesn't guarantee